Now in this video we are going to study about the scientific notations and comparing the quantities with each other using the scientific notation. Our success criteria is to use the scientific notation to describe a very large or very small quantities and to compare these quantities with each other. Now, the first question is, what is scientific notation? Actually, it is used by mathematicians or engineers or accountants or the people who deals with the finance to write or to express very large or very small numbers. And it makes the calculation very easy. Now, whenever we talk about scientific notation, it consists of three parts. So you can see on the left hand side here, I have written one number which is written in the form of scientific notation. So this number, you can see that there is a number here with a decimal. Okay. And now this decimal comes after the digit between 1 and 10. Okay, it should not be 10, it should be 1 till 10. It means 1 2 3 4 5 6 7 8 9, and after that we have to put a decimal. So always the decimal comes after the first digit, and this is said to be collectively as coefficient. Then we have to put the sign of multiply, and then we have to write anything in the form of base and exponent. So we know already, we have studied that the number which is on the floor, it is called the base, and anything which is written in the air on that base is said to be exponent. So there are three parts of writing a scientific notation: coefficient, exponent, and base. Now understand one thing, that what are the different rules of writing the scientific notation. Scientific notations number should be, as I said, between 1 and 10, and it has to be multiplied by the power of 10. Means you cannot write 2 to the power of 4. No. The power base must be 10, which carries any number. It could be a positive whole number or it could be a negative whole number. Any number with a positive sign or a negative sign, but the base must be 10. Now look at this one. Okay, this number 23 times 10 to the power of 5. It is not the proper scientific notation. Figure out why. Now pause the video, find out your answer, and if you find out, very nice, just try to clear the doubts and listen to me. Here it is 23, right? And I said that the number must be between 1 to 10. It means it could be 1, 2, 3, 4, 5, 6, 7, 8 or 9. Even the number couldn't be 10 or greater than 10. Whereas here the number is 23. So which means it is not the proper scientific notation. Explain you how can we change a number into scientific form. So let's suppose I have a number 2340005. Let's suppose this is my number. Okay, now look at the number and change it into a scientific notation. Okay, here we are going to write in the scientific notation. So where is the decimal? I can't see any decimal, which means that the decimal is at the end of the number. Now, in order to write into the scientific notation, we know that the number must be between 1 and 9. It means this first number, I have to move the decimal and put a decimal between the first and the second digit. So let's see. So what I am going to do, I am going to move this decimal to the left side. So I am going and I am moving to the left side. So how many digits? Let's see. 1, 2, 3, 4 and 5. So my decimal comes over here now. So let me write, okay. So 2 point and write everything whatever you get and then put a multiply sign. Then always put a 10. Now where did you move? You move towards the left side. So when you move to change or the standard form into scientific notation towards the left side, you put the plus power. So how many places you moved? You moved 5 places, right? So you moved 5 places towards the left. So write it as a plus 5. Let's try to do the same way. One more question. Let's suppose it is 962. Okay, this is my number. Change it into the scientific notation. So where is the decimal? The decimal is after the 2 because I can't see it. I have to move it after the first digit. It means between the first and the second digit. So this is the point place I have to move. So how many I will move where? I will move towards the left. Okay. So from the right, I am moving towards the left. Okay. So let's see here. 1 and 2. So I will move 2 digits. So I will write 9.62 times 10 to the power of 2. Get it? So when I move from the right to the left, I have to put the power with the plus sign. And how many digits or how many places I am moving, it will be indicated by the power. The decimal should be always be after the first digit. Let's try your turn. So 670953. Let's see this thing. How can you do this one? So where is the decimal point? Of course, I can't see. It means here is the decimal point. Where do I need the decimal point? I need here, right? So how much I will move? Let's check how many places I have to move. 1, 2, 3, 4 and 5 places. So how do I write my scientific notation? 6.7 and everything as it is. Then I write multiply 10. I move to the left 5 places. So the power will be 5. Okay, let's try more. If I already have, let's suppose 523.67. Now here what have you seen that I already have a decimal. So is it at the proper place to write or express in the scientific notation? No. Why? Because the decimal must be after the first digit. So what I have to do? Again, move the decimal. No matter where it was, just move it. Okay, so where are you moving? You are moving to the left, right? So move 1 place and 2 place, right? So here is your decimal. So how do you write? 5 point, then write 2367 times, again write 10. How many places you move the decimal? 2. And since you are moving towards the left, so it has to be positive sign. Okay, one more and then we will do the other thing. So 72.894 and let's do this one. Is it on the correct place? No, it is not at the correct place. So what you will do, you have to move it and put the decimal here. Move where? Towards the left. So you will get 7.2894 times 10. And how many places you move to the left? Only 1 place. So here is the 1. That's all. Now let's try and move to the other kind of the question. Now see the question 0.000539. Now what have you seen that here there is already a decimal. Now tell me, can you move to the left? If you move to the left, here there is nothing. And I need a number between 1 to 10. Which means now I have to move to the right side. Okay, so I have to move to the right side where I could find a digit. So I can see the first digit is 5. Okay, so which means that I must move to the right side. So let's start moving the right side. So 1, here 2, here 3, and then 4. Right? So I move to the 4 places, but where? To the right side. So when I move, what I get? 5 point and the rest as it is, and 10 then multiply by 10 as it is. Since I am moving to the right, so the power should be represented by a negative sign. And how many places? 4 places. So put the power 5, but with a negative sign. Okay, let's do the practice. If you still have the confusion, let's do more practice. 6. Okay. Now, where I will have a decimal? Over here, right? So, where I will move? This is the digit. Where I will move? After the first digits. So, let's try to write it down. Move to the right. 1, 2, 3, and 4. So, again I have 4 places, right? So I will write 9.6 multiply 10 and 4 places. Since I am moving to the right, so minus first and then I will write 4 places. Let's do one more. 0. Okay, 0.01356. Okay, let's practice one more. Where are you going to move? You are going to move to the right. Okay, now how many places? 1, 2, and 3. So my answer will be 1.356 times 10, 3 places. It means to the right minus and then 3 places means 3 on the as an exponent. Now let's practice some questions from the textbook. Now look at the question. This is the word problem, and I have seen that most of the students, they just scared of the word problems. So the tip is that whenever you look at the word problem, don't get afraid. See what is the main idea and what they are asking you by underlining or circling the important things. A group of researchers in Hawaii estimated that the number of the grains of the sand in the earth on the earth is that much. Now write this number in scientific notation. So there is a number and you have to only write in the scientific notation. So what have you seen that the number is very big. What you have to do only, there is no decimal in the middle or anywhere. The decimal is at the end, which means that you have to move to the left. So you know that whenever you move to the left, the power will be positive. Okay, so where you need the decimal, you need the decimal after the first digit. So let's move. How many times you will move? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. So you will write 7.5. Now after the 5, you see in the end there are a lot of zeros. So after the decimal, if there are 0, that means something. But in the end, yani after the 5, if you put 100 zeros, it has no sense. So no need to write the zeros after in the end of the decimal things. Now then we have to write what? We have to write 10. And how many places we have moved? We have moved 18 places towards the left. So it means the 18 will be with the positive sign. Let's check the next word problem. A snail moves across a table at a rate of 0.00093 miles per hour. Now write it in the scientific notation. So when you have a word, very small word, and you want to move the decimal to the right side after the first digit, it means after the 9. So once you move to the right, you have to make a negative power or exponent. Now let's see how much you will move. 1, 2, 3 and 4. So it means 4 places you move to the right. So you will write 9.3 times 10 to the power of 4 places, but to the right it means minus 4. I hope that the idea is clear. These questions now, write in the scientific notation. So the first thing is, where is the decimal? At the end. Where will you move? To the left, which means the power will be positive. And digit, where you will find the decimal after the first digit. So let's try to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So we will write 2.39, and I said that in the end we don't write the zeros. So after that we will write multiply 10 to the power of how many places we saw? 3, 6, 9, 10, 11. So it will be 11. Now here next question number 5, 405. Where it is the decimal? Over here. Where we will move? To the left. How many digits? How many places? 1, 2. Okay, so what do we write? 4.05 into 10 to the power of, the power will be positive. Okay. In question number 6, where do you want to move? To the right. Right? To the right. After where? After the first digit. So let's try to move and count the places. 1, 2, 3, 4 and 5. So we will move 5 places. Where? To the right, and to the right means the power will be negative. Okay, so what we will write? 1.01 times 10 to the power of 5, but with negative sign. So never write the negative after the 5. Always write before 5. Finish question number 7. That is, move to the right, which means the decimal, which means that after the first digit, that is the first digit, right? 6. Let's try to move towards the right, means the power or the exponent will be negative. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So we will write 6 times, okay, 10 to the power of 14. But since we were moving to the right, so it will be negative. Now in the scientific notation, you don't write the decimal alone. So after the decimal there is nothing. So you put yourself 0.0. So that is the perfect way to write the scientific notation. And I told you that after the decimal, if you write the 0, and alone 0, it has no value. But it is the nice way to write this scientific notation. Now look at the idea. Okay, now the idea is that we have, for example, a scientific notation is given to me. Okay, so 10 to the power of 2. Now it is a little bit different. So when you have the positive power, you move to the right. Okay, you move to the right, and when you have same thing, let's suppose this one, negative power, you move to the left. Means the idea is opposite. Remember, in the standard form, if we move to the left, we put the positive power. But if we move to the right, we put the negative power. But here, when you convert this, means reverse the process, then if the power is positive, it means move the decimal to the right side. And if the power is negative, it means that move the decimal towards the left side. Okay, let's try to do this one. 4.3, right? So I am writing 4.3 as it is. 10 to the power of 2. Power is 2. It means I will move to the right. Okay, so right means I will move my decimal. So here it is the one place and this is the second place. Now in the second place there is emptiness. Okay, there is nothing. So what I will do, I will put the 0 myself. So decimal I already moved, right? So it will be 430. Okay, let's try the second example. 4.3, 10 to the power of negative 2. Left, it means if the power is negative, we move to the left. Okay, how we will write and move to the left? It is 4.3, right? Move two places to the left. So one place and two place, right? So when we put this here, so here you move, you will empty place, you put the 0. Now the decimal comes here. Now there is nothing before the decimal, so you always put the 0. So what is our answer? Our answer is 0.043. Remember, you can't write the two decimal at the same in the same digit. Only one decimal at a time. Okay, let's try question number 1 and question number 3. Okay, now question number 1 says 8.9 into 10 to the power of 5. Okay, first of all, write it. Okay, 8.9, right? 10 to the power of 5, it means that where you will move to the right side, right? Okay, 1, 2, 3, 4, and 5, right? Okay, in the end, we don't put the decimal. So now, in the empty places, you just put the zeros. Now, in the end is decimal, we don't write. But in the starting, if this is the decimal, we write a 0 before that one. Okay, so how do we write it? We write 8, 9, 1, 2, 3, 4 zeros. Now, you try this one. 2.1 into 10 to the power of 7. Okay, so 2.1 and 10 to the power of 7. So move to the right. 1, 2, 3, 4, 5, 6, 7. Okay, so 1, 2, 3, 4, 5, 6 over here. Okay, so what is the answer? 2, 1 and 1, 2, 3, 4, 5, 6. Now this is the way we are writing the standard form. But the question was not this line. The question is that which number is greater. Either this number is greater or this number is greater, and don't solve it, just give the answer. So how can you give the answer? You can see that the first number is 8.9, okay? And the second number is 2.1. Okay, we can say 8.9 is bigger than 2.1, but this is not the way we will see. We will see that after the decimal, after one digit there is a decimal, and here also in the second part, also after one decimal there is a decimal. So we will compare only the powers, that which power is bigger. Either 10 power 7 is bigger or 10 power 5 is bigger. Of course 10 power 7 is bigger because 10 is multiplying 7 times. So that's why you can directly say that this is 2.1 into 10 to the power 7 is bigger than 8.9 into 10 to the power of 5, because the power of 2.1 is bigger than the power of 8.9. Let me just erase this part to understand this in the proper way. So which one is bigger? 2.1 into 10 power 7 is bigger. This sign is for the greater. Whenever you have like this, so the open mouth shows this is the greater sign. Okay, greater than the 8.9 into 10 to the power of 5. Now look at this one. Question number 2. Write in scientific notation. Where will you move? You will move to the right. And when we move to the right, you remember that we write in the from standard to scientific. Moving to the right means negative exponent. So where we will put the point? After the 5. So we will get 5.01 into 10 to the power of negative, and how many places we move? 1, 2, 3, 4. So negative 4. Okay. Now here is the opposite form. Means when you move 5.31 into 10 to the power of 3. So when you will have the positive power, again you have to move the decimal towards the right. So let's see, 3 places, 1 place, 2 place and 3 place. It means at the empty places you have to write the decimal, you have to write the zeros. So 5300. Okay, now the question is so scary, but it is so easy. So I am skipping everything which is not for my use. I will only understand, and I will only understand the question which is important for me. You can use the scientific notation in order to find the small, write the small numbers. The thickness of the dollar bill is about 0.0043 inches. Write this quantity in the scientific notation. So to move the decimal, we have to move until the first digits come, and the first digit should be between 1 and 10. Okay, so when the decimal moves how many places? 1, 2, 3 places, right? Remove the extra zeros to get the first factor. Okay, so we will write what? 4.3. Now, how to write it? How to write it? It is 4.3. We are moving to the right side. Whenever we move the right side, it has to be with the negative power. And how many places we move? We move 3 places. So we will write negative 3. Next question. In 2016, the United States Mint produced about this much pennies. Write this quantity in a standard form. Now, whenever use the power of 10 to determine how many places you have to move. So you have to move 9 places here. Okay. So you have to move 9 places. The reason is the power is 9. Okay. So when we move the 9 places, let's see, there was empty place. Okay. Look at this one. So 9.1. 9 places. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So at the empty places, we always put the zeros. And when we put the zeros in the standard form, we don't write the point over here. And in the end also we don't write. So what will it be? 9, 1, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is our answer.